Here we have the geometry engine, and looking at the little tag it says that this is a GE14, which means that this is an Infinite Reality 2, not an Infinite Reality 3. I'm so full of it. Anyway, again we can see we have a CPOP connector, this one much smaller, with the nice big long threaded rods here. And we have 4 geometry engines. Now I know those are the geometry engines for sure because it is a G14-4, which means 4 geometry engines. The only other G14 is the G14-2, which is the Reality, or a cut down Infinite Reality 2, and only has 2 engines. You can see, however, that there are pads for 4 more. That would be the Infinite Reality 3 that I don't have. What these are, I have no idea. I think that those are the geometry distribution units, which takes the graphics information off the bus from system memory and then works out how to spread it across the 4 geometry engines. Here is the raster manager card. As you can see, we have a whole stack of chips on here with memory on either side, 2 memory chips to each row, to each chip. Now the board is actually double stacked. And I would destack it for you and let you see the other stuff, but I don't have my Torx bits here today. Suffice to say, however, if you could see in between them, there'd be a whole lot more of things like this. Again, I said this is all some pretty scary magic to me, but this performs. Now let's check Wikipedia here. What have we got? Scan conversion, color and depth interpolation, perspective corrected, texture coordinate interpolation, and level of detail computation, which sounds really cool. Way to go, SGI. On to the next board. And finally we have the display generator. As you can see, a whole bunch of, well, empty pads actually. We have a bunch more custom ASICs. As you can see, everything is labeled SGI. I mean, this entire graphics set is custom hardware. These units can be double stacked to make, as you can see there's only 2 outputs on this, they can be double stacked to make 8. I'm guessing this is the power and the data connector for that. On the back we have 2 monitors, 0 and 1. We've got S-Video, 2 composite outs, one's RCA, the other BNC. We've got stereo view, and then the gen locks and the swap ready line. I found in the manual a bit more of a description as to what it is this thing does. Now according to this, it scan converts triangle data from the triangle bus into pixel data. It then organizes the data into a series of spans, or vertical strips of pixels, and transfers it to the frame buffer. Makes sense. I don't know why I didn't get it before. The last thing I thought I would show you is the IO6G module. Now, it doesn't look like much from the front, but in the back, it's really quite a nifty piece of stuff. We have all of the keyboard, mouse, serial, parallel. There's even a SCSI controller on board in there, hooked in with this lovely little connecting device thingamajigget here. To the XIO bus. The XIO bus is these slots here. Now the IO6G baseboard always sits in this top slot, but we have a double wide slot here and then 2 single wides. Now you can stick all sorts of XIO cards in here. FDDI, HIPI, you could have multi Ethernet cards, you know, like the ones that have 4 Ethernet slots on them, stuff like that, Ethernet switches. But you can also get these nifty little things that sit in here that do PCI conversion. So you slot your PCI card down into it, and then the entire unit slides into one of these XIO slots, and you can add PCI cards to your system. Pretty cool. So, what is it good for? Well, this one, a rather impressive and very purple end table. When it did work, I didn't use it often, to be honest, mostly to fiddle around with IREX and play with the demos. So what are the production units used for? As a high-end workstation, you can use them to manipulate graphics and video, as well as to do relatively quick test renderings. They were used by Weta, for example, on The Lord of the Rings with their computer-generated imagery. Boeing may have used this one for high-end design applications, building objects up and easily viewing and manipulating them in a 3-dimensional world. This provides a simple way to see how components interact with each other before you build them, as well as to see the loads and stresses they place on each other. They can also be used for video processing, of course. They even still have the Genlog port standard. How about immersive virtual reality? In a fully surrounding virtual environment, pack several Onyx2s together in a couple of racks and you very quickly have the processing power and graphics pipelines required to provide surrounding video feeds for a set of projectors, as in a cave. Visualization is precisely as it sounds, being able to see data in a way that makes it easier to process by humans than it could ever have been done on a spreadsheet or even on paper. The Onyx2s did the job, and pretty well at that.